Okay. All right, take a seat, please, so we can get started. All right. I would suggest you get your formula sheet out, okay, and your materials, because we will be adding a couple of formulas to that, okay. Oops, I'm going the wrong way. Okay. Before we go any further, I'm going to pause this for just a moment. Okay, so one of the things I want to ask you about, for instance, from prior knowledge, okay, if you are experiencing static friction, what might that be? Is Anna here?
Shock. No.
Okay.
Yeah, shock when you like rub
Okay, so,
or rub your feet on the car.
well, that might be true, but that's static electricity, not static friction. Okay?
It's your tires on the cement.
Right, it's your tires on, for instance, concrete, asphalt, cement, any one of those. Okay, so what that means is, what's the difference between static friction and sliding friction? Just tell me.
Sliding for roll.
Yeah, it's moving if it's sliding friction. Okay? So what that means then is, if you are trying to do work, that object has to move. And if it doesn't move, are you doing work? The answer to that would be no. All right? So, anyway, or if there is no movement being done, you're not doing any work. Because this is where we left off with yesterday, right? We talked about this. Okay. You have to have a direction. Okay. You have to be applying. Yes.
I cannot find my sheet for that.
You said he fell. I wasn't here yesterday.
All right. So what about if you're pushing up against the wall? Obviously, the wall's not moving. You can do as much work as you think you are doing, but again, if there is zero net movement, you are not doing any work. That's what we're trying to explain here. An example is, as you carry your books, either in your hands or your backpacks, if you are not moving them books, you are not doing any work on them. Why is that if it's in your backpack?
Because you're not holding them your phone.
Yeah, because they're not moving. That's what we're trying to illustrate. Okay? So again, if there is zero net movement, you're not doing any work on that. Now, why would something like that be significant or important? Well, could be pressure ratings, for instance, on different types of mechanical pieces of equipment. How much work can it endure? How much horsepower? Now, some of you are asking questions about horsepower yesterday. Okay? Now, horsepower is just a measurement. It's not designating that one horse is going to do a certain amount of work. It's just a rating, for instance. Okay? That's all it is. Don't get hung up on one horse does more work than another. It's just a specific definition of how much work is actually being done. Okay. So, moving forward. Do you have this content then? Okay. I just want to make sure we're all caught up. Okay. So again, whether the books are in your hand or in your backpack, they're just moving horizontally. fine. Nervous?
Yeah, I feel like you're gonna steal my meat.
I see that phone down there.
Huh?
I see that phone down there.
That's his calculator. Where at?
Right here. Stand up.
Oh my pipe.
An extra hash on our worksheet.
Yeah.
I'm sorry, what? Extra hash.
Hash.
Oh, well,
Like a hash brown.
I call it dash. That's what confused
Hash
me.
and a dash are the same thing.
Oh, I did not know
I
that.
don't know. I don't know.
Take my meat.
Okay. So we see your next formula that we would like to have you put on your formula sheet.
It's horsepower. I butchered mine last year by myself.
Not quite yet.
Oh. Skin.
No.
Wash.
It's right here.
What would that be?
You're capable of reading, yeah.
What's force of X? The best thing to do is you kill him
When you see two variables next to one another, what does that mean? You're multiplying. That's what we're illustrating here. That's why it says or work equals force times distance.
Lasers scare me because one time when I was little, my step cousin, he had a laser, and he brightened me in the eye with it, and then I have PTSD from lasers.
Well, these are green.
Is that distance?
No, I'm sorry. Nope, these are red. That's right. I'm looking at the button. That's green.
The red lasers are scary.
Well, it allows you something to follow along with what we're talking about.
Those are red dot lasers. My cat was like aiming a laser at the floor, so I like chased it. My cat got it right in my eye. I can see for the rest of the day.
Okay, we might be stopping. Okay, yeah. So on your formula sheet, put that information there. W, or work, equals a force measured in what? How do you measure forces? Newtons. How do you measure distance, would you believe? Meters. Okay? Now, this work is going to be what we call a derived unit. Okay? And it's measured in joules. Okay? If you know anything about, well, not necessarily heat transfer, but old engines about the turn of the, well, not the turn of the century, somewhere around in the 1800s, I believe, James Joule, okay, came up with heat transfer for locomotive engines, okay? So with that, the amount of energy transferred there is named after him. That's why we call them joules. Has to do with the type of gas you pump through there. Okay. So does everyone have this content that wants it? I'm sorry, I must be standing in your way.
So what do you put, just force and then X in parentheses?
Or you can put WFD.
What was I know?
W equals F.
Well, that's what it's illustrating, yes.
And so what do you write to label it?
Work,
Like, yeah.
joules. J. J is fine. Okay. Can we shut this off then?
Yep. Yeah.
We're gonna watch another video.
No, we're not quite done yet because we're problem solving here. It is? Oh. Oh, is my collar not down? Oh.
You popping your collar now.
I didn't get the pop. I didn't get
Okay.
the Papa Chuck.
Okay. All right. So to help you out here, how much work is done by a crane that lifts a 1370 or 1,370 kilogram I-beam from the ground to a height of 43 meters in 4 seconds. We'll probably work on this bottom problem first. So sorry, I should have maybe let you know that, but we're going to do both of them regardless. I don't know the mechanisms of a manual transmission, but
Do you know
well,
how
I
to run
suppose.
a manual transmission?
Sure. Anyone who's probably grown up on a farm can probably do that. Yeah.
You know how to slam gears in a semi?
No, I've driven semi truck, but it was an automatic transmission. It wasn't manual.
Nick's is an automatic too.
Yeah, I have an automatic, unfortunately.
No.
I just have 3 pedals to make it look like I'm cruising.
Just to make it look like who's not a female.
Yeah, I'm compensating for something, you know. That's how it goes.
The loss of.
Okay. Then the second one says, as you push start a truck, you're moving at 1.15 meters per second squared. After 12 meters, your friend releases the clutch on the 9,000 on the 910 kilogram truck.
Do you have a push start?
You can't do that on automatics.
Yeah, you can only do it with
Only do it with manuals.
manual. Because you pull it, you get it on, then you pull it in gear.
Oh, you can go backwards too. You can do it in reverse. Mhm. That's what I was trying to explain. I'm not quite sure of the internal mechanisms. I know you got a clutch plate. When you push that in, it takes the power off the drivetrain. Then you release the clutch, it pushes the power back on. And how that happens, I'm not sure of that internal mechanism. Joules. Yeah. I'm right in your way all the time, aren't I? I'm going to go over to the other side of the room here.
You pull start a truck. Pull start.
All right, can we proceed with the bottom problem first? Okay, so you've read the problem, just like any other time. What should you do?
Set up.
Okay, so in this case, remember, we've got work
Acceleration.
equals force times distance, and the amount of work is measured in joules. Forces, of course, are measured in newtons, and this distance is measured in meters. So what you could say is a newton per meter is also a joule. Okay? So that's what we mean by a derived unit. A newton per meter is also a joule. All right. So what do we know in that bottom problem?
Oh, we got 12 meters.
You got your accelerator.
Okay? So what is the acceleration?
1.15.
Okay? That's not a very good 2, is it?
And then your distance is 12 meters.
I got the virus.
Okay?
And then your mass is 910 kilograms.
Now, we want to know what the work is. Okay? Oh, I guess it doesn't say how much work is performed. Okay? How much work is done? Okay? So, what 2 things do you need to know to solve for work? Force and distance, right? But we don't have either one of those. But can we solve for anything with our setup there? You have the distance, right? Right. So your mass times acceleration will give you your force. That's right. Okay.
I can't get a calculator out.
So our force equals 910 times 1.15.
4,046.5.
Okay, and of course that is measured in newtons. Okay, so now that we have our 1046.50 newtons, you multiply that by what? 12, and that will give you your amount of work in joules. So in short, work equals 1046.50 times down here, which is 12. So 12,558 joules. Okay. Now, for those of you watching this, I think that's what we got from your classmates. 12,558 joules. Okay.
Who's gone today?
Any questions on that bottom one?
Is Anna sick?
Okay. This top one might be a little more tricky. So, what are we going to do in that top problem?
You gotta set it off.
Right. So, what variables do we have? Okay.
1570,
What else do we know?
your distance, 43 meters, and your time. 4.10 seconds.
The acceleration is
Acceleration equals 900. How?
No.
No.
Nope. Okay. Now, if you're lifting that crane from the ground, or lifting the crane, sorry. If you are lifting that I-beam from the ground, here's our I-beam sitting on the desk here. Is it moving? No. So we have an initial velocity of what?
0.
Okay. So an initial velocity of 0 meters per second. Do we have a final velocity?
Not yet.
No, because we need an acceleration, right?
Oh, you could do your distance divided by your time.
Okay, that's correct. So our distance, 43 divided by 4.10.
10.49.
10.49.
Okay. Now, how do we solve for your acceleration for that?
Oh, you're going to do your final velocity subtract by your initial, and then you're going to divide that by your time as well.
Yeah.
So acceleration. Okay, did everyone catch that?
Yeah, that was simple.
How do we calculate acceleration?
Final velocity minus initial velocity.
And since we got 0 here, that's not going to make any difference. 10.49, because if we subtract 0, it just gives you the same number. Our acceleration is what?
Roughly
2.56.
Meters per second what?
Squared.
Okay. I'm sorry, I should have been doing this for you.
I'm right on it.
Okay, so this is half of it. Now we've got our acceleration. No, we're not. Now we need to find the force. And how do we do that?
I believe that's going to be your mass times your acceleration.
Your mass times your acceleration. That is correct.
350. Holy.
3,507.2.
Joules.
That's Newton.
Okay, so help me out here. Force equals what? 1370.
3507.
Point what?
3507.2.
And that's in newtons now. Then to finalize that, work equals what? 3507.20 times what? 43.
150,809.6.
150,809.6.
And that's measured in what?
Joules.
Okay. We went through that really fast.
But it was real easy, so.
Left side here.
Great. We're great.
Oh, yeah.
I'm doing good.
Oh, yeah.
Best in the game.
We're asking, do you understand? We're asking, do you understand? Okay. Middle. Middle.
Come on, rev it, bro. Rev it.
Okay, right side.
Can I just
All right.
two-step on your avalanche?
Okay, we're going to continue watching that video, so that's all I have for class now. So we will catch up to you next time.